All right. Now listen, when you start doing this at home, I put a lot of information on here for you. Go back and review it. Don't just try to name it and then give up. If I've got all this information on here that tells you how to do this stuff. You took notes yesterday. You took notes last week. We've been doing this stuff. You should be able to do this stuff. But the more times you read it, the more likely you are to have it, to own it. Okay? So I've given you all these prefixes in here you need to know. All right. Now there's two categories of physical acids. Two categories of physical acids we don't need to know how to name. One of them is binary acids. And the other is, we're going to call them oxyacids. Oxyacids. Okay? Now, binary acids are just two elements. Remember, binary compounds are two elements, and I've got the definition for you right here on the sheet. All right? All acids have to have hydrogen in the front. All acids have to have hydrogen in the front, at least in this class. Okay? So binary acids will be some hydrogen attached to something else, some anion. Okay? We're going to say it's just an A, just for calling. That's our symbol for anion. Okay? Yes. No. Okay? All right. Oxyacids are those acids that have a polyatomic ion that contains oxygen. Okay? All these polyatomic ions on your common ions list that have oxygen in them, you can make acids that have this polyatomic ion with the oxygen that's called an oxyacid. Okay? So there's a different naming system for this. These oxyacids then contain polyatomic oxyanions, negatively charged particles, that's what an anion is, with oxygen in it. Polyatomic meaning there's more than one element covalently bonded together. Now binary has one sort of exception to it. There's a couple of compounds, actually only one that really applies to acids, where we name the acid, an acid with a polyatomic ion, the same as binary because it has no oxygen in it. So binary also includes just the hydrogen on front of an anion. That's all it means. Okay? It's kind of a general formula for all acids. So binary also includes the polyatomic ions or anions without oxygen. Okay? All right, we're fast running out of time, so I'm just going to have to hit this really, really fast for you, okay? But the instructions are on the worksheet.
Is it going to be on the test tomorrow?
Well, yeah, we'll have time to go over it again tomorrow, but the instruction on the worksheet, okay? Now, for all the acids, you name them first like ionic compounds, okay? You first name them like ionic compounds. So here's an acid. It's got hydrogen on the front. It's got an anion on the back. If we name this like an ionic compound, how do we name it? What do we call this? Hydrogen fluoride. Hydrogen only has one oxidation number, or only one positive oxidation number, so we don't need a Roman numeral. And the fluorine becomes a fluoride. Okay? Now here's how we name binary acids. Remember, binary means two elements, not necessarily just two atoms. The way we do this is we're going to drop the gin. Okay? Gin's not good for anybody. We're going to drop the gin. Okay? And we're going to we're going to change the ID ending to IC. Hydrofluoric acid.
So you put it all together like one word?
Yes. That's why I drew this here. You put them together. Okay? So this is, and you put the word acid on the end, so this is hydrofluoric acid when you're done.
Where did the acid come from?
That's what you do for an acid. Hydrofluoric acid. Okay? All right, let's try one more. Now you name this one real quick. Well, I don't know if we have time to do it real quick or not, because I still have to go through the oxyacids. Well, let me name this for you, okay? All right, so what we have here is,
Hydrogen.
no, not di. That only apply. Di is only used when it's covalent. We're naming these like ionic compounds first. Hydrogen sulfide. Okay.
That's gonna be hydrosulfide.
Yes. Now with sulfur and phosphorus, we put that U R O R back on there. It sounds a little better. Hydrosulfuric. Okay. Okay. So hydrosulfuric acid. Okay. All right. Oxyacids.
You don't add the 2 in there?
Nope. Ionic compounds, you don't do that. You don't have this one?
How did that shit look?
How do we know to change it to sulfur?
Well, only sulfur and phosphorus do that. Only sulfur and phosphorus do that, okay? All right. Oxyacids. All the ions that have oxygen in them have either ite or ate endings, okay? All the polyatomic ions with oxygen in them, except for hydroxide, have ite or ate endings, okay? So let's look at this one right here, H2SO4. We're going to name this like an ionic compound. This is sulfate. SO42 negative is sulfate. So name it like an ionic compound. It's hydrogen sulfate. Okay? For oxyacids, we're going to drop the hydrogen altogether.
So the sulfur?
And we're going to, exactly, we're going to put the IC back on, and with sulfur we put the UR on there too. So this is simply sulfuric acid. If it's concentrated, it's very strong. Yes, what's in your car battery?
So the anion name would be...
So this is a sulfate anion, and we change it to sulfuric. Okay? So 8s become ic. Hydrogen drops off for the oxyacids. All right, hold on, don't put it away yet. Hold on. Let's look at this one. What's the name of this anion? Come on, I just wrote up there. Huh? That's not sulfate anymore. What is that?
Wait a minute, I saw it on the page.
Sulfite. So if we name it like an ionic compound, it's hydrogen sulfite. Okay? Alright. 8s, we change to ic. Okay? Ites, we're going to change to OUS. Drop the hydrogen off. So this is sulfurous acid. There you go. There you go. All right, now look, you've got a few minutes left in class. I'd start this acid chart and practice a little bit before you go. See if you can get a few under your belt before you have to go, okay? Yep.